To model a vector field, the vector field class constructs lines in 3D space showing the direction of the vectors. The tail of each vector is situated at equally spaced points in 3D space, forming a 3D grid. The length of each vector shows the strength of the vector at that point. In my program, the vector field class represents the 3D model, which consists of vertices and edges. The density of the vector field model is configurable by changing the vertex count in x, y, and z dimensions. The number of vectors is the product of the vertex count in each of the 3 dimensions, and the number of vertices is double the number of vectors. That's because each vector has 2 points with one edge connecting them. There's an edge to describe each vector, and this class is where I construct the edges. The next task is to set up the data for the vertices. This is done in the function vector field class. The function vector field class has a function called setVertexArray. This function loops through x, y, and z values and assigns the tail and the tip of each vector. The tail is simply the x, y, and z values, while the tip is based on the function and the tail coordinates. The tip of the vector is calculating by calling getDeltaVector of each of the subclasses. Next, to display the vector field, since I already set up the vector field representation to be a standard 3D model in my program, displaying the vector field is easy. The trickier part is to show the right amount of detail. If the vector field is too sparse, there's not enough information to visualize the vector field, and if the vector field is too dense, it's too difficult to see what's going on. For my testing, the right balance is a few layers in the z direction with the full coordinates in x, y for each layer.